basically collects information about the oil and chemical spills from various states. Here is a link to the data set. And this visualization, basically our team built it on Tableau, and it shows that Hartford has the highest count in Connecticut. Then we started with importing modules and preparing the data. So first of all, we imported the data set, and then we began understanding the data. So these are some commands which shows the number of rows and number of nulls. And then we started with cleaning the data set. So we saw the number of nulls. And for removing the columns, we took 20% as the threshold. And accordingly, after that, we removed some rows which had nulls. Then we began with the area part. So in this, we have shown some interesting visualizations. So the first one shows spill incidents per year. As you can see that 2001 had the highest number of spills. Then town-wise spill incidents. You can see that Hartford has the highest number of spills. Then spill cause, so MV accident followed by others. In this one, we have visualized the total spill quantity per year. So 2006 has the highest spill quantity, followed by 2001 and 2011. And then we visualize the release type. So petroleum has the highest count, followed by the others. Now I'll hand it over to Sahib for data enrichment.
Emerging part. We found this dataset on the internet from a website called mdat.pe. Now, this is a source which contains core data on the occurrence and effects of over 22,000 mass disasters in the world from 1900 till present date. We used this dataset to enhance our original dataset to see the number of people affected, injuries happened, and the CPI index from the spillage. Now, the dataset that we selected is a subset of a huge core data that contains 48 columns and 41 rows. We went through the same data cleansing part we did earlier, and then we are left with 21 columns in the end, removing the null values. Then comes the merging part. And the merging, we took two keys basically, that was state and the year or the spill that happened. And after that, we come to the visualization. These are the visualizations, but the major one that I want to focus is this carbon performance index. Now we observe a strong trend over the years which tells the rise in CPI index, and it reflects the rising concern about the impact it has on the environment, causing the mass pollution of environmental bodies and the number of lives affected by the spillage. Now Karishma will explain about the optimization.
Solution in this field, identify all the possible solutions that can be made. We imported the data file again, and we did the data filtering for the towns that are assigned to our team. We did some data cleaning, and we removed the missing values from the column total quantity gallons. We also removed special characters like less than, greater than, or approximately from total quantity gallons to perform arithmetic operations on that column. Our first problem is to minimize the sum of repair times. The repair time is given as total gallons spilled divided by total number of crews assigned to that particular city. And therefore, our objective function is here, given by this. We have some constraints that each city should at least have one crew assigned to it, and the total number of crews that can be assigned to all the three cities should be equal to 10. We have grouped by and found the total quantity gallons for each of the towns. We have created our optimization model over here. We declared the constraints, we declared the minimum number of crews that can be assigned, and then we created a for loop which will go from the range 1 to 8 for each city. And we found a best repair time. We printed the results over here with the minimum repair time and the crews assigned respectively. In our second optimization problem, we have to minimize the maximum amount of repair time that any city can take. So our objective function over here becomes minimize the maximum of the repair time for each of the city. It is kind of similar to the first optimization, just our decision variable is different over here. The for loop is same with the range of 1 to 8 for each city, and we stored the minimum of maximum repair time over here, and we printed the results over here. The problem findings, and according to the problem findings, the recommendation for CTT would be to assign maximum number of crews to Fairfield, because it takes a lot of time and it has more spill over there. To optimize the solution, they have to assign more crews to Fairfield. Thank you.